जब बात एजुकेशन की हो तो हमें अपने फ्यूचर के साथ बिल्कुल समझौता नहीं करना चाहिए।
मेरा 19 सालों का अनुभव मुझे ये बताता है कि बोर्ड की परीक्षा में और मेडिकल प्रवेश परीक्षा में क्या पूछा जाता है। जो वो पूछते हैं वही मैं पढ़ाता हूँ।
एकलव्या आपको लाइव क्लासेस के साथ साथ डाउट सेशंस भी देगा, जिसमें आप अपने डाउट्स यहीं पर क्लियर कर सकते हैं हमारे बेस्ट टीचर्स के साथ।
दिल्ली के बेस्ट टीचर एकलव्य की टीम में शामिल हैं। आप भारत में कहीं भी रहते हो उनसे पढ़ाई कर सकते हैं। लैपटॉप या मोबाइल के माध्यम से हमसे जुड़िए, हमारी लाइव क्लासेस ज्वाइन कीजिए, चैनल को सब्सक्राइब करिए।
बहुत टिपिकल कंसेप्ट्स अब एनिमेटेड वीडियोस के थ्रू बहुत इजी हो जाने वाले हैं।
फिजिक्स, केमिस्ट्री, मैथ, बायोलॉजी अब कुछ भी कठिन नहीं होगा।
एकलव्य एजुकेशन बोर्ड्स के बच्चों के लिए 10th और 12th के लिए लेकर आया है एक क्रैश कोर्स।
इसी प्लेटफॉर्म को ज्वाइन कीजिए और 3 महीने में हम सारा सिलेबस आपको कंप्लीट कराएंगे। साथ में मॉडल पेपर और नोट्स भी प्रोवाइड कराएंगे।
एकलव्या पिछले 15 सालों से बहुत सारे टॉपर्स दे रहा है, इसीलिए हम भी चाहते हैं आप भी टॉपर्स बने हमारे साथ।
Hello everyone, myself again Gautam Banerjee from Eklavya Institute of Sciences, taking physics. Hope you were there last time when I took the few portions of Newton's laws of motion and elevator. We discussed about the motion apparent weight of a person in an elevator or a lift. Little bit of first law of motion we discussed, second law we discussed, and third law we discussed. So from there, let us discuss something about connected motion. Today we are going to do connected motion related problems. How to solve, which is called FBD, that is free body diagram. Free body diagram. How to define, how to divide the forces on a particular object, and how to solve the questions for mechanics that we are going to discuss over here. Now, when we are discussing about the free body diagram, the very first thing we should not forget that the very important part is we are going to take up pulley related questions. This is a pulley. Now, point of suspension. This is the two bodies which are connected with. We take this pulley as a frictionless pulley. Two masses connected to it. There can be innumerable masses connected to the string. There can be another string. There can be 2-3 masses which can be, there can be another pulley over here. So this is just a general case. Let us first find out from a basic one how to find out the acceleration, tension from this diagram. Now, first of all, we need to draw the forces. This is a frictionless pulley and we say the string is inextensible. We take the pulley has got no mass, that is massless, and from there these are the two mass. This is M1 and this is M2. Now the motion is along this direction. So the acceleration of this body is downward and here the acceleration of this body is A upward. Obviously, when this body is coming down, this has to go up. Now the weight of this mass will act downward, and action and reaction. Definitely when this string, due to this, there will be a reaction force of this mass on the string, that is called tension T, which is upward. Here also, mass of this body, that's weight, is acting downwards, and tension T again upward, action reaction. Why the T same? Because it is of the same string. If there are some other string, then there might be difference, or there may be same also, but it depends what the question says. Suppose other string of other material, definitely different tension. Now we need to calculate, general cases we need to calculate tension T and acceleration A. So free body diagram, what does it says actually? Now we'll come back to this. Hope you all have drawn this. In this free body diagram, we are suppose there might be so many, like here we have got two masses, there can be three, there can be four. Now how to solve them? See, we take this as in equilibrium. We consider that they are in equilibrium. Now with this equilibrium of motion. So with that fact, what we do, we take up one by one. Suppose we concentrate on this body first. Free body, we forget about this. First we concentrate on this. Or you can take this, forget about that. So one by one we take up. Suppose we are taking this body. Now here it is mass M1, weight acting downward as we have done. Acceleration downward means body is moving downward, and there is a tension T which we have done. Again, we can form an equation. Body is moving down, so definitely this component is greater than that component. So what we can do, the equation number 1, M1A is equal to M1G minus T. This is equation number 1. Done. One equation is over. Now we are going to take about this one. Forget about that body concern. Just total concentration should be on this body. Let's make this body again. This is M2. Again the weight acting downwards, tension T upwards, but here the body is moving upward. Component T will be greater than, it has to be greater than this. So the equation will be M2A will be equal to T minus M2G. Now see, we got two equations. How many unknown we have? 2. Solving these two, we can get the formula, the expression for finding out acceleration and tension. Like the very first thing, let us divide one divided by 2. One divided by 2. So when you divide them, just simply write down the equation. See what is coming out. M1G minus T upon T minus M2G. So with this, there is a cross multiplication you do, and with this cross multiplication you can get the value of tension T. So tension T will be, how to find out? So T minus M2G, M1 equal to M2 multiplied by M1G minus t. Now, all of you know mathematics is a very basic mathematics. With this, we have to find out the value of t. Hope you all are calculating with me. So, let's take what we have to do. Just bringing that t over here, just make it out. m1t minus m1 m2g will be equal to m1 m2g minus m2t. This you have got. m1 plus m2 t, which will be equal to twice of m1 m2g. Hope now you have understood the value of twice, that is t, twice of m1 m2g upon m1 plus m2. So students, you can very well understand how easy it becomes when we use the free body component. That means when we divide this and we form two equations. Suppose there are three pulleys. I mean, one more connecting with one pulley. There is another object. Fine. Again, we'll divide it into three. So what does free body diagram does? It actually makes our calculation more convenient, which otherwise would be very, very difficult when you try to solve. So now students, you have got the value of t. Nothing to tell you, all of you are mathematics students. Now from t, we can definitely get, picking up any two equation, you can get the value of a. Just substituting the value. So let's get at the value of a also. Now this is the value of t we have got. So we need to find out the value of acceleration. We have got the equations as I already told you. m1a equal to m2g minus t. This was one equation which we had. That's enough. We can substitute over there. So m1a becomes equal to m2g minus twice of m1 m2g upon m1 plus m2. You know how to find out? Nothing to. So the value of t after substituting here, you definitely get the value of acceleration. Now what is the value of acceleration you get? That is, obviously we can understand, that is m1 minus m2 upon m1 minus m2 upon m1 plus m2 whole multiplied g. So from this we will get this. So students, today this connected motion has been brought into some notice that whenever we are talking about connected motion, the meaning connected motion is this. See, the object which is connected to a string, then inside a pulley, and when it is moving, the motion, the study of the motion of those objects, then that is actually connected motion. And then there are the parameters which we calculate. So this is how we do find out accordingly. What I would suggest to you, please don't try to learn these expressions, because when you learn these expressions, actually definitely you will forget it faster. Instead of doing that, you understand the concept, how we have derived it. So if you keep that concept in mind and accordingly you do, irrespective of any number of objects which is connected to the pulleys, you would be able to solve any equations, because it is not this is just a general way of finding out. I have shown you there can be 3, there can be 4. So accordingly you can divide and you can find out. And there are a lot of numericals based on this which is given in your NCERT also. There are other books which you are following, so you should definitely do from them. Now, from here, we are going to enter into another part of very important part of laws of motion, that is where that's called friction. See, we say if we bring laws of motion, the first law of motion, there is one thing which we always understand. The law we definitely understand that it says a body, when it is traveling in a straight line, or if the body is at rest, its state of motion or rest can then only be changed. I'm just not exactly stating the law, but I'm telling you, I'm explaining you, which you also know, that unless and until we apply an external force or any external or any if that motion is being subjected to any external force, then only either its state of rest or of motion will be altered. Otherwise, in whichever position or in whichever situation that body is, that will continue. Now, interesting part. We say a body in motion will continue to do so, but होता नहीं है. बॉडी अगर मोशन में है तो वो रुक जाता है अपने आप ही. वी डोंट नीड एनीथिंग, बट दिमाग में चलता है, अरे यार ये क्या हो गया. फाइनली आई थिंक ओके, ये तो लॉज ऑफ मोशन सेज कि ओके फाइन, फर्स्ट लॉ न्यूटन सेड कि वो तो चलता रहेगा. नहीं, unless until an external force is applied. So external force does not mean कि always we have to stop it, or there has to be a wall, or there has to be a wooden block or something like that. नहीं, not now. Constantly there is a opposing force acting between the surfaces of the two bodies, and that opposition force or opposing force is known as friction. That opposing force is known as friction. Now, friction, when we talk about friction, there was a kind of, like there was a origin was there. Actually, initially there were old concepts like, it depends upon the area of contact. Then it actually, when the surface is very smooth, the friction is very less. No. But the modern concept is little different from that. It is independent of area of contact. Why? The reason being, it depends on the actual area of contact. If you talk about, suppose a body, suppose I'm moving my hand like this, palm. If you notice, when we are keeping the palm, my complete palm is not in contact with this. There are few points which are actually in contact with the both surface. So, when we say it is dependent on area of contact, no, that's wrong actually. Because actual area of contact hota hi kitna hai? It's very small, at points there. Let's talk about a wheel. When it's moving, it is in connection with the road. It is attached to the surface of the road, but only this much portion. Only this much portion. So this is the wheel only. Actually, see, this is the portion of contact actually. So it's the actual area of contact, which is very, very small, very, very less. So friction, it's an opposing force. Why? Because it is because of the friction, the motion of a body is objected and it stops. That is one thing which we need to understand. Now, friction, there are kinds of frictions, definitely. First one is static friction. When we talk about static friction, what is this word static friction?